Okay, today we're going to talk about bits and bytes. It's important to understand this because the next thing we'll talk about is character encoding. Character encoding is a way that, for example, if you consider your smartphone, your cell phone, it uses the UTF character encoding. That lets it display Latin, which you could call English, but it's Latin, Greek, Chinese, Arabic character sets, plus the non-displayable characters like the tab. So in order to understand that, you need to understand what bits and bytes are. Okay, a bit is something like this. 1, 2, 3, 4, 5, 6, 7, 8. All right. On modern computer systems, on most computer systems, one letter, like the letter A, is equal to 8 bits. Okay, and it turns out that A is ASCII code 65. Okay, we'll build up to how do you make that. All right, in order to understand the bit system, you need to understand the decimal system. All right, for example, this number here, 65, is the decimal system, meaning the way we write our numbers, like let's look at something larger, 2,565. What is that? This is equal to 2 times 10 cubed plus 5 times 10 squared plus 6 times 10 to the first power plus 5 times 10 to the 0 power. Okay, what is 10 to the 0 power? It's just 1. Any number raised to the power of 0 is equal to 1. So let's see if this is true. Might have to put parentheses, I don't know. It's true, right? So what is this number equal to? It's equal to this. All right. Now if we do this again, now notice in the decimal system we use the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, in the binary system we use just 0 and 1. So for example, if we want to write 6, the number 6 is equal to 1 times 2 squared plus 1 times 2 to the first plus 0 times 2 to the 0 power. This is the same thing as 1 times 4 plus 1 times 2 plus 0 times 1. All right, so let's run this, see what it is. Run it like this to make it a little easier to see. It's 6. Now you write this in binary, you write it as 1, 0, 0. 1, 1, 0. But since we want to talk a bit about bits, we put 4 zeros in front of it usually. 1, 2, 3, 4, 5, 6, 7. That's 6, 7. Okay, 1 less. Now, so to convert a hexadecimal number like this Back to an integer, you use the int function. Okay? And then here we put what base numbering system it is. It's base 16. So that's 428 as we showed. Here, let's convert this binary number, base 2, back to an integer. This is 2, right? It's 1 times 2 to the first power. All right, that's it. The next video will be about character encoding. It will be more complicated, but it's built upon this basis.